Where's the thermostat in this house?
It's over here. See if we get the same thing here in this bathroom. Same as those, I mean, 59, 64, 67.
$62 at the wall, $63 at the wall. About 2 or 3 foot in, we're at 64, 63.9. 63 point, yeah. Okay, then stay there, Jim, so you use your foot.
You're about 6 feet.
6 feet, we're at 65.
Interesting.
Mm-hmm.
And why over here though? Well, this is the cold, that's over in the coldest section of the house.
That's colder over there.
That's the coldest section. We have the garage protecting us here.
Exactly, we got a
That's
little
Over here,
ambient
we got-
protection,
we got that.
semi-conditioned,
Yeah.
or, you know, whatever you want to call it.
Smile, Randy.
Check this bedroom where we did all our measurements.
And you got to take pictures in there too.
Oh yeah, let's do that. The battery's about ready to die. Okay. Oh, damn it, I pushed the power button.
Slayton. Okay, I got to meet a guy down there, an appraiser down there, and I told him I'd buy him lunch. So I'm out. Yeah, he wants to try our green chili stew.
0454
Okay, I'm doing a little work. I'll call you in a minute.
0.
Bye.
454 or 454. That's top plate.
4. I'm sorry. What was it?
454.
4, 5, 4. Top plate.
Yep.
Okay.
Top of window is 455.
Okay.
Bottom of window is 456.
Okay.
Four, 5, 7 is bottom plate. You still can see that
No matter what, they're transmitting.
they're
energy.
losing a lot of energy,
Yeah.
and we're not. You know what I mean?
Yeah.
So even though that their sub-slab temperature was the same,
All right. So if we add another column, so if we said this is the baseline, so they have to go against the baseline. The top plate had a -2, and this one had a 3162 is 31, right, Jimbo?
31 and 62?
Yeah.
62 minus 31.
Correct.
And then this one is 17, 18, 19. Right? And then 10, 11, 13.
okay.
The bigger the delta,
Mm-hmm.
the better, right?
Mm-hmm.
Even against this.
Mm-hmm.
Or the smaller would be better.
No, on that one it would be smaller, wouldn't it?
Let's look. So obviously this one is a +5. And this one is a -7.
Seven.
And this
Eight.
one is
I should
-8.
have brought pizza for you guys, huh?
And this one
17.
-17.
Hamburgers or something.
So our worst part of our assembly is our slab.
Mm-hmm. And theirs.
Is the bottom is the windows. Is the worst. Very interesting.
But that's what we were saying last night.
That was a concern, wasn't it? On their floor, now here's their pull-out. 50 to 56, 58 to 60.
Okay.
So over 6 feet, they gain 10 degrees. Depending on which way we would go, if we do over the same 6 feet in the same place, right, we gain 11. Not much difference. Now, again,
No.
the question is how did they, and we don't know with that house, how they insulated the slab.
Right, we don't know.
But
What we do know is that near our edge, we're approximately the same temperature, okay? But
our delta is better.
exactly, because it doesn't matter if we're heating up the home right now, and we know that hot's going to cold, correct? And so the amount of BTUs that are going to the edge are different in our home compared to their home, because it's still negative 15 outside in our home versus 6 degrees on the outside. So what we're seeing is more BTU absorption into their edge assembly than our edge assembly, even though that they're staying at the same temperature.
So our heat is, or our energy is trying to go hot to cold, and it's stopping right at the wall.
Exactly. Our energy is getting there. We know that in majority of all homes in the United States in a heating dominated climate, that edge is going to be colder. However, we have a protection of insulation that we're backing it up, that we're absorbing to there. But what's happening with them is it's absorbing through.
It's
So
creeping
they're
out.
losing more BTUs going this way and going out, and we're absorbing our BTUs. We know that, but we're holding it and we're not letting it go out. So. Yeah, that's what that's. That's an important factor, because that's
What, the outside temperature
That's 21 degrees difference
versus the two houses.
versus the two houses. That's 21 degrees difference. So that means
They're losing 21 degrees
they're
worth of their
losing 21
heat.
degrees more
of
than
their
we are.
energy. Yeah.
Exactly. And that's an important part. They're losing 21 degrees more
Energy.
than we are.
Yeah.
So even though that these two numbers,
Because this number over here, that's a reoccurring number because the heater's on. It will keep supplying that energy. It is
The
surprising.
question is how much of it's leaking out to warm up the outside.
Now, all right, now here's something else to look here. See, how would we convey this? Set points. Okay, their set point is 67, but their wall, which is our baseline, is 5 degrees less. Here we have a thermal mass gain of 13.
right?
That's something to look at as we do these.
I think you can attribute that to air tightness too, Tom.
I would agree with you there.
know.
I would agree.
Because we did see in the bad assembly, or the blown, whatever they currently
got.
use, but we did see more variation between their wall cavity than what
Than
we
here.
saw here. So we saw a dip and a gain.
Now, we did that wall over there, and that has a truss header. We were doing truss headers here, right? Yeah, we were. These will be solid headers when you get charged up. Now, it's got a porch, so it's protected a little bit against solar gain. It would be interesting to see what the headers look like, these being solid.
These
headers.
being solid.
Yeah. So we want to do that,
Let me grab it.
and then do the attic, and then take pictures on the outside, and then we'll get out Reba's hair.
Oh, yeah. It's interesting.
We're really not going to know the full effect until we get about, we get about 10 houses put together.
Yeah, then
See
you
if we
got
see
some
it.
more.